My name's Adrian Graham. I'm a cloud solutions architect at Google, work out of Los Angeles. And I come from a visual effects background. I spent the last 20 years or so working in visual effects in pipeline and effects animation. And one of my jobs here at Google is to figure out how to run those workloads on the cloud. So the extension behind that is how do we run those workloads in a secure manner that follow the compliance requirements of not only the big six studios, but all along the line, all the way down to handle any type of content. There's certain requirements that you might have gone through the auditing process by different bodies such as the MPAA or the ISE audit process. But what we're going to talk about today is how to build a hybrid structure on Google Cloud to share with your on-prem and how to secure all the components within. So like I said, we're going to, if we look at the flow here, we're going to build a little diagram and talk about the components that make up a secure system, and then we're going to go in more into depth of how we secure all those components. So we'll start by looking at what our on-prem, what your on-prem solution might represent. And think of this as starting with like a small business. We're going to start with a few workstations, and they're just networked together. But of course, we're going to have to go and add a file server because we need somewhere to store massive amounts of data and files and to share them. We're going to want a license server because at some point we're going to have third-party software that needs to be licensed. And then those licenses are going to need to feed not only the local workstations, but your render workers. And again, this is on-prem, so we're talking about a bunch of blades and a bunch of racks in a machine room that you have to pay for power and cooling and HVAC and maintenance and have somebody run them. And so now our pseudo company is getting a little more sophisticated, so we're going to implement a queue manager. Now, what we're seeing here today, I'm biased because I come from a visual effects animation background. So we're seeing what represents one of those types of companies. But this could apply to almost any company that deals with large amounts of compute that requires lots of storage and lots of network. So I apologize if it's a little bent towards the VFX idea of pipeline. But when we talk about a queue manager, if you're not familiar with products like Cube by Pipeline Effects or Deadline by ThinkBox, it's essentially job deployment and management so that you've got job dependencies and all those things running. Queue manager is typically run on a server that has some sort of a database structure that can talk to an asset management system. So now we've gotten even more sophisticated where we've got our whole system controlled and asset versions built out of the asset management system, fed to a queue manager. The render workers are speaking back to the asset management to declare and publish and everything. So that's our on-prem infrastructure, a very simple overview of it. How do we do the same thing in the cloud? So first, we're going to skip the workstations because we're going to assume that because we're running a hybrid workflow, everything's going to come from on-prem. So we'll start with our rendering VMs. And when we talk about render VMs, these could be tens or hundreds or thousands of virtual CPUs of instances running in the cloud, up to hundreds of thousands of cores. It doesn't matter the size of the job, but what does matter is that you can control them in a safe and easily manageable way with different mechanisms that GCP offers, such as managed instance groups. And then we're not right now going to worry about how we get the data in and out of the system. That's why we have the dotted lines. Don't worry about that. We'll talk about that in a bit. So we have, next up is our storage in a similar way to the data, the file server on our on-prem side. We've got our asset storage and GCS, which is an object store. We'll talk a bit more about different types of storage in a bit. And speaking of which, we're going to introduce an NFS file server. Now, there is a place for both of these types of storage in typical pipelines like this. They depend on your needs, and we could talk about that in a little bit further. And there's also different types of virtual appliances, such as the Avir VFXT, that combine a read-through cache and an NFS file system so that you could reduce your ingress and egress costs and the load and the throughput and everything. Now we're going to emulate our cloud-based, our license server by putting a license server in the cloud. And this could just be a single vCPU machine with a small amount of memory that speaks to not only your cloud instances, but also your on-prem. You could feed your license server from over a VPN that way, if you like. Next, we're going to, and this is a bigger discussion, to talk about IAM, which is Identity Access Management. This is a way of organizing and managing permissions and authorization through users and groups and different roles, and we'll talk about that a little further later. And finally, we've got the ability to collect logs. Logging is pretty important, obviously, in any workflow, but what we're doing here with Stackdriver is collecting the thousands of streams of logs that come out of the render workers, but Stackdriver does more than that, and we'll talk about that in a bit. Excuse me. So we have the two halves. Now, how do we connect them? And how do you connect your facility to the cloud? So first, because this is a security and compliance talk, we have to recommend we use a VPN. Almost any auditing process is going to require this. You need to secure your connection and encrypt the data that's traveling from your on-prem location to the Google Cloud Platform. But there's other components that we need to add to make sure that this remains secure. It's a cloud router. If you've got multiple networks on the GCP side, you need to be able to synchronize those routes. And then there's the actual connection between your facility and GCP, and there's a few different options there. In this example, we're going to implement Cloud Interconnect, which is a service that we offer that allows you to connect your facility through a local ISP if you're not near a point of presence, which we'll talk about a little later in terms of peering. Cloud Interconnect offers reduced latency and better throughput than a typical connection. So that's how we connect the two. Now let's zoom back, although we don't have that much space, to look at the whole overview. So here we've put it all together, and I've had to sort of crunch it in the middle. That's that big blue line. Cloud Interconnect should be in the middle there. But what can we add to this? How do we go further? Well, we can synchronize our user base and your Google domain with your on-prem directory service, like an LDAP server. There's something called Google Cloud Directory Sync, which permits you to do that. So this means that users that have things like admin access on, excuse me, on your facility side can have the same types of permissions and belong to the same types of groups on the GCP side. Finally, I skipped over that slide there. Finally, there are other ways to securely transfer data from on-prem to the cloud, and that's via our APIs and our SDKs. And you can see down in the bottom left-hand corner there. That node indicates some pipelining that facilities typically do, and that's to transfer data via gcloud or gsutil. Those are tools that we supply that have the same authentication and authorization levels of security that VPN does and that IAM and they're classified under the IAM user base. So you can transfer data back and forth that way to either cloud storage or directly to and from an instance. And then there's this optional accelerated UDP transfer, which we'll talk about in a bit, but it's essentially third-party utilities that allow for parallel transfer. So now that we have the whole the landscape mapped out, what do we do with it? Well, first we need to understand how the resource hierarchy functions. And we've got this notion of policy inheritance, and you could think of that like a Unix file system. And the root node is your organization. Your organization typically will be your company domain or your company name. And then under your organization, permissions, you could set permissions and ownership and different levels of permission at the root level, the organization level, and that passes down through your project level. Projects we'll talk about those further in a second, but the permissions that are defined in the organization level will pass down through the project level. Projects can have their own authentication and access roles defined, and those pass down to resources. So that you've got certain owners you might have a master owner or owners of an organization, and then you have individual owners of a project that can't change other projects. And that's sort of the basis of how IAM functions. Projects are the main unit of separation between all data on GCP. Projects cannot speak with each other. They have individual networks that are defined within each project, and by default, they cannot communicate outside, so that there's a secure boundary layer defined within the project's structure and hierarchy. There are ways to access data across projects. There's a new product that we just introduced at Next called Cross-Project Networking, or XPN, I believe we call it. That's going to be rolled out shortly. I believe it's in beta right now. You can ask more about it later. And then there's there's a GitHub repository that we've open sourced called Forseti Security, which helps you perform automated security checks on at the organization and project level that you want to run. You'll want to run on a regular basis to ensure that there's compliance is followed within your project hierarchy and structure. Any changes that are made will be part of the audit trail and available for viewing, and also it'll send up alerts and allow you to see a dashboard of changes that were made. All right, so we've spoken about cloud IAM a little bit. We'll go into a little bit more on the next slide. But I want to talk about service accounts and access scopes. These are ways to now further refine your security profile. Service accounts are like a special Google account that will run resources. Instead of launching a job on a render worker, for example, an individual user won't deploy that instance. A service account will deploy that instance. And a service account has certain permissions and roles assigned to it that only permit that instance to do certain things and access certain resources. And you can refine that even further with something called access scopes, which is essentially refining the permissions of a particular resource or an instance such that it can only perform certain actions. For example, a resource could be an instance running a license server, and a resource can be an instance as a render worker. And the license server only needs to access certain parts of the network, or only needs to publish over a certain port, and it should only be able to accept information from a certain IP range, for example. But a render worker needs a little bit wider permissions. So you can assign different access scopes when you launch each individual resource, each individual instance, to further refine how much reach and scope they have. All right, so to focus a little bit more on IAM, we've got the who can do what on which resource. Who is defined as what type of user, whether it's a user group, service account like we spoke about, that's the blue lines, the blue boxes up there. When we talk about roles in terms of who can do what, the roles and authorization tokens are defined under a list of roles, predefined roles or custom roles, and each of them has customizable access to different resources. And those could be created from scratch, or we could use a bunch of, there's primitive roles, which include owner, editor, and viewer, which are the simplified versions, and then there's much more customized versions of those. And then resources, we keep talking about resources, but they're not just instances, they're also storage and networks and subnetworks and that type of thing. One more thing I want to say about IAM is that it really gives you an overall master view of how what the security profile is and what the permission stack is amongst your whole project. And if you're at the organization level, the organization as well. The cool thing about it is that if you make modifications, you don't need to restart any of the resources for the changes to take effect, and they're transmitted instantly across the tens or hundreds or thousands of resources on your network. All right, so we've talked about permissions and resources. What about encryption? Now, we're going to speak a little bit more about encryption throughout the rest of this presentation. But I want to talk about how the data is encrypted. Google provides encryption with, there's a mechanism that is defined by two different types of keys. There's what's called a data encryption key and a key encryption key. Now when data is encrypted on GCP, prior to encryption, it's broken up into chunks, and that chunk is encrypted with a data encryption key. That chunk is stored on a resource somewhere, on storage. As an example, this is data at rest, by the way. Data in transit flows across networks. We're not talking about that right now. We're talking about data at rest. So we've got the chunks broken up amongst different, even spinning disks or SSDs, whatever you have defined your storage profile as. which also means that if somehow one device is compromised, they only have the one small chunk of your data and it can't be reassembled. But we've got the data chunk and it's been encrypted with the data encryption key. That data encryption key itself is encrypted, or what we call wrapped, by the key encryption key. And the key encryption key isn't stored with the chunk. It's stored on a key store or key management system that is globally distributed and fully redundant. So that means that in order to access your data, you need to be able to unwrap the data encryption key, and you need access and authorization through IAM to read the key encryption key. So in that scenario, we manage the keys for you. Some pipelines require some auditing processes, and compliance requirements mean that you have to store your keys on-prem. And I know that there's some financial services business models out there that require this. You can manage the keys yourself. It can be complicated depending on the size of your key store. We do offer a service called Cloud KMS, Key Management Service, that will provide you with an API and a front end to do this yourself if you really have to. Click. Okay, I spoke briefly about networks, but let's go a little more, excuse me, a little more in depth. Not unlike projects, networks are another way of refining the security profile and ensuring that data does not leave a particular area. Now, I'm going to use the VFX and animation industry as an example this time. You can have multiple networks, each with their own flow of data, each with their own data content. So, for example, we could have a separate network just for simulation, a separate network just for animation or for rendering 3D animation, and another network for running composites, and finally another network for transcoding. And each of those networks can be customized based on the load and the flow, the requirement needs of any individual pipeline. If you want to look at that from a security standpoint as well, if you have a sequence in a film or a shot in a film, or even a sequence of shots that are in a trailer, for example, that have a higher stronger security need than the rest of the film or the rest of the project, you can isolate that on its own network and only provide access to a limited set of individuals to that network. So that means people can be on the project that you assign authorization just to that network, and the rest of the artists or managers or owners or whatever don't have access to this separate network. Resources are positioned on networks that cannot be reached by other networks. You can do cross-network communication, and there's ways to do that through, among other things, firewalls. Firewall rules, everybody should be familiar with in the on-prem notion, but our firewall rules are centrally managed in the same way that you manage users under IAM. But the cool thing is that you can assign, the changes that you make don't need to be deployed, and resources don't need to be restarted. They take effect immediately, but you can also you can deny traffic and from variable ports. You can also assign tags to specific resources so that traffic can only flow to resources with those tags, which I think is pretty cool, so that you don't need to manage IP ranges or anything like that. And lastly, you can prevent an instance from launching, or sorry, you can launch an instance and prevent it from acquiring an external IP address. As a matter of fact, you could specify that by default to not generate an external IP address. And that means that the instance itself will only be accessible from within the network, from other resources on the network, or across your VPN. Obviously, you need to have some external IP address for your VPN gateway, but that's all taken care of with a managed VPN. So when we launch an instance, we have to choose what kind of disk image to deploy it with. And we supply all the standard, as part of our public images, we supply all the standard OSs, CentOS 7 and 6 and 7, different flavors of Ubuntu, different flavors of Windows Server as well. And all the licensing is taken care of for you. So if you run Windows or Red Hat, and the licensing model is all included, you don't need to bring your own licenses. But what we've done is we've sort of carefully curated these instances such that, first of all, they're a minimal install. Everything is extremely locked down, to the point that if you install third-party software on your own instances, you will most likely have to install additional supporting packages. But we also have installed, and we provide, should you want to do a custom instance, there's a set of packages that we provide that allow for GCP communication to your instance that's specific to things like IAM and resource deployment and communication with Stackdriver and that sort of thing. So you could choose to bring your own custom instance, take the instance that you run on-prem for your own render workers, for example, and simply deploy that to the cloud, but you're going to have to make modifications. And we have instructions, we have documentation online that shows you how to do that. We do recommend, however, that I recommend at least, having done this a few times, to take one of our public instances and modify it for your own uses. Add the software that you need, the license hooks that you need, and the libraries that you need, and then save that off as an image that will then become your ideal render worker. I'll be giving a talk later on after lunch on GPUs, and I actually show how you go about doing this and deploy your own instance and what it could be used for. All right, so we spoke a little bit about VPN, but now I want to cover the couple different ways that you can connect to GCP. And the initial example that I gave, excuse me, is via Cloud Interconnect. There is another level up called direct peering. Google has over 100 points of presence around the world, edge points of presence, which means that we have our hardware in a data center that is hooked directly into Google's private network. And if you have if you're of the proper location in a major metropolitan area, and you have you've met a certain level of requirements, you can directly peer to Google, and that's the fastest, most secure connection. One step down is Cloud Interconnect, which is still secure, but you have to connect to a public ISP. But as soon as you're on the ISP, we've partnered with most ISPs in the world that will provide you with a entry point into our private network. We spoke about instances and instance management, but let's talk about storage. When you launch an instance, you choose the boot disk. And that can be considered attached storage. You don't really use that for any type of network storage because it's really only accessible to that one instance. But we have the ability to deploy separate storage models that could be attached at any point to any type of resource associated with any resource. We spoke earlier about object-based storage. GCS, or Google Cloud Storage, is object-based, which means that it's infinitely expandable and highly durable. However, because it's object-based, it's not path-based as a POSIX-compliant storage, an NFS storage would be. So you're going to need to modify your pipeline to address, to draw on that, to read or write to object storage in a bit of a different format. And we could talk about that a little later if you like. We do offer different types of PD, or persistent disk, as POSIX-compliant NFS based storage, and those will be subject to different types of storage. So there's spinning disk or SSD that can go up to 64 terabytes in size. And you can also have what we call a single node filer, which essentially allows you to connect, which runs a file server on the cloud that allows you to connect hundreds or thousands of instances to it concurrently. But there are other file system solutions that you might want to explore, some third party and some that we're partnered with, to provide you with things like read-through cache or multi-file server solutions. So we spoke about encryption at rest earlier, but what about encryption in transit? The point I want to hit on this slide is you have a VPN connection to from your facility to GCP. The data is encrypted the second that it enters our network. If the data has already been encrypted from your own VPN router, the data will be decrypted and then re-encrypted using our AES 256 structure, at which point it will remain encrypted in transit until it becomes written to disk. Then it's subject to the data key and the key encryption keys that I spoke about earlier. Spoke a little bit about the SDK and the API, this GS util and G Cloud utilities I keep talking about. But what's important to note about them is that they're under the same authentication and authorization models of OAuth 2 tool set that are implemented elsewhere in our whole security stack. If you need to run outside of these two tools, such as rsync or SSH, you could generate your own key to be able to communicate securely with an instance or a resource, but you need to manage those keys yourself. So it could be a little bit painful having to manage those. So it is a lot easier to just use things like the SDKs that we provide. I spoke about UDP-based transfer a little bit earlier. There are a number here that you could, third-party solutions that you see up on screen. We don't manage those, so we can't guarantee their level of security. Most of them do run under a secure model, but of course you're responsible for complying with the requirements that your facility lays out. Stackdriver, I'm kind of really interested in because I'm a sort of a big pipeline nerd, and the ability to collect tens or hundreds of thousands of logging streams concurrently is really interesting to me. The fact that you can run this logging server on the cloud, and not only can you collect your cloud logs, but also your on-prem logs. You could use Stackdriver with an open connection to your on-prem render workers to collect your logs. And then you could take these logs, and I'm actually working on a solution now for this, so stay tuned. You could take these logs and move them into a searchable database, a Cloud SQL database, so that you could run BigQuery commands on it and dig deeper into the contents of these logs. Audit logging is sort of a subset of Stackdriver in that these logs are different because they are non-editable and they cannot be deleted. Audit logging occurs when changes are made to your network at the admin level, changes are made to your project at the admin level, or any type of modification to metadata related to your project. So these are logs that you will want to investigate or provide if something changes unexpectedly on your system to see who did, like we said with IAM, who did what on what resource. And lastly, and this slide is sort of geared towards the visual effects and animation realm, but if you want to talk about queue management, there's a lot of, there are some solutions out there, so, like I said earlier, Cube and Deadline, that already have cloud integration and offer cloud licensing models so that you can run their software either on-prem, or a better solution is to even run your queue management server on the cloud that can control your on-prem and cloud instances. If you have custom software implementation that has things like a Python API, and you want to be able to pipeline your software into to implement it with your GCP projects, we do provide APIs that will authenticate and authorize in the same way, the same fashion that you do through the GSUtil and gcloud commands. And finally, licensing. Yes, you can use your own on-prem server to serve licenses on the cloud, but what happens if you exceed your bandwidth allocation, or if you want to run hundreds of thousands of cores on the cloud and you need to provide licenses for all that? It's a much better idea to run your license server on the cloud, and it's an even more secure model to run it even in a separate project that serves all of your other projects. Now that means that you will only have a single resource on this license server project, and that's the single instance serving licenses. And yes, it will have a public IP address so that it can speak with other projects, unless you use cross-project networking, which we could talk about offline. But there's really, you've really minimized your risk because you only have a single resource visible on that project with a single port opened up. You guys will get these slides in, I think, PDF form available after the show. And I really, really encourage you to read through this documentation, these links that I've provided here. They give you a much, much more high-level view, drill really, really deep into the security best practices that you should really be following if you want to align with the security considerations and structures that are laid out for your business model.